So a piecewise function looks something like this. It's a function that has not one rule, but multiple rules, and each of those rules are applied to a certain interval. For instance, this one, f of x is equal to the rule negative x for all x's that are less than 0, so that's on the left side of the coordinate grid. F of x is equal to x squared for all x values between 0 and 1, where 0 and 1 are both included. So another way to write that is 0 to 1. And then finally, f of x is equal to just 1, so a horizontal line for all x values greater than 1. The graph of this function will look like three separate curves or lines put together. Here it is. Here's negative x for all x's that are less than 0. I'm going to use y here. Y equals negative x. Here's y equals x squared between 0 and 1. And finally, to the right of 1, all x is greater than 1, we have y equals 1. So a piecewise function is going to be a function with multiple rules, sometimes 2, sometimes 3, sometimes even more. The absolute value function is one with which you are very familiar. It's defined actually as a piecewise function. You use the rule y equals negative x for all x is less than 0, and you use the rule y equals x for all x is greater than or equal to 0, and the graph of the absolute value function often looks like a V. As we see, well, I can try that again. As we see here, it is two lines connected. Next are composite functions. We say that a composite function, it's written like this, but it's read f of g of x. It's one function plugged into another function. It's made by composing g and f in the order of working g first and then f. I like to refer to g as the inside function, f as the outside function. Inside first, outside next. This notation can be used up here with parentheses, but also you may see the notation f with a little circle read of f of g. This is where we often in early algebra classes or pre-calc classes call these fog and Goff problems because of the notation of the little circle. But what they mean are composite functions work the inside function into the outside function. Here's an example of a composite function. Find a formula for f of g of x. If g of x is x squared and f of x is x minus 7, then find f of g of 2. So f of g of x, if g is x squared and f of x is x minus 7. So we're going to take the function g and plug it into the function f. So the function f is x minus 7. Instead of x minus 7, we're going to plug in the entire function g. It's x squared. So this f of g of x is x squared minus 7. Finally then, what is f of g of 2? Well, that would be 2 squared minus 7, or 4 minus 7, which is negative 3. Composite functions. There's the solution. Hey, we got the same thing. That's pretty cool. And that will do it for piecewise absolute value and composite functions.